Welcome back. So today we are supposed to be checking this take profit thing, but I actually want to know that what we have done is useful, and that means that we aren't we aren't working with so many. What's the other? I don't remember the name. So I want to check that when I'm in main.py and I do this thing about the start new cycle, that I don't. Let me see. How do I explain this? Yeah, so that I know how many symbols do we have on all of this. So here we have active symbols, whatever. If we resume, but if we are not resuming, we have here like how many filter symbols do we have and so on. So that's a bit more or less what they want to be doing here. So we have a first filter symbol by age and volume, which yeah. So basically, let me check what the hell do we do here. First place, because I want to check exactly what we do here. So it's trading symbols. So trading symbols. So when we filter symbols by age and volume, we first of all we make sure that the symbols are old. Okay. And so we make sure that the symbols are old, and then we also make sure that the symbols are the top volumes. So maybe this thing. Wait a minute. And then we remove the excluded symbols. Now that I see this thing here, we are doing this always, and maybe doesn't make any sense each time we start new cycle to check this thing. Update symbol registry with filtered symbols. Yeah, set up symbol modes. Wait a minute. Yeah, we're definitely doing too many things when we try to do the stuff. So we try to run the cycle, and then when there's a cycle, we start a new cycle. With this start new cycle. So either we start right away, or we start when everything is closed. The problem that I have seen here is that if you don't resume, you are going to edit the database, which makes sense. You're going to get the market summary from BTSE again, and so on, and all of these can be cached so that we are not getting all of this stuff again and again. Also, we don't need to filter symbols by age and volume each time we do this thing. Actually, what we actually want to be doing is just classify train by range, which I guess uses the 10 whatever, and then place all positions. Yeah, so we're going to optimize all of this so that you know, noun symbols db.init, which means just I mean, this should be quite fast because it's local. But maybe if we don't need to do this, there's no need to do it. So let me check real quick. What the hell is this? Noun symbols db.init. Do we need to do this? Is this something that we need to do? So from db noun symbols, which is this thing here, we do an init, which is execute create table if not exists. So this is going to check in the file disk. It's going to try to open the database and so on. So this we can avoid doing all of this if we just add this thing like, you know, each time you run a start new cycle, you can say something like noun symbols db. Wait a second. I mean, actually, each time you run this command, you are going to init, or don't you? Noun symbols db. Get ready symbol. So I only need to check if this is done once. So the only problem that I have right now is where the hell do I store? Maybe in a state. But I wonder if it's a good idea to store this thing into state, if you ask me. So it would be something like state, something like noun symbols init. Noun symbols db was init, so this is by default false. And then basically what you do is, if not, so I think you can do if not this thing, you then init. Otherwise, yeah, if this was not init, you init. Otherwise, you don't need to do that. And then I guess that you can. So this is a state dot whatever, and I guess that the state where we are importing everything. Import the state, yeah, that's true. We're importing everything. So so if this is false, then you init stuff and you say that this is true. That way we are fine. Okay, because the init one it's not doing anything. Like, just create this thing, which should be already done once. So we add this thing and state.pi, and we say initialize known symbols db only once. So we are avoiding initializing this many more times that they should be doing. Then, so fetch market summary from BTSE. This should be only done once. You don't want to fetch the summary each time you do a new cycle. So you want to wait like 48 hours before doing this. So I need to check how this is supposed to be working so that this is cached properly the same way we are caching everything else. So let me just check real quick. So this is done in exchange BTC. So exchange BTC, which is this thing here. We have get market summary. Okay, look at that. Get market summary. It already has a market summary cache, which we are doing here. So the question is, premium market summary cache. How often do we do this? If it's none, you do nothing. And okay, so we are using, oh my god, market summary catch timeout. Only 5 minutes. So my question is, are we using something from here? Filter symbols by age, and volume. Yeah, age and volume. We can just use age and volume from here. So my question is if we are using this for the price, but I don't think so. Okay, so let's do hours 24 or 48. So we are going to do this thing, you know, every 2 days. We don't want to get in this thing each time and each time. Actually, we could do something else instead of 48 hours, because we already have something 48 hours. But you know, so if this difference between the timestamp and the UTC now is greater than the catch timeout, then you return known, so that it tries to get it. Okay, so this is a good implementation, like market summary expires instead than in 5 minutes. Hello, viewer. You can say something in the chat if you want to. So once we have managed market summary, then we filter symbols by age and volume. So maybe we can also try to speed up filter symbols by age and volume, which is from trading symbols. I mean, why do we have to update anything if we have already done it? you know what I mean. So filter symbols, is it like here, isn't it? Filter symbols by age and volume takes the market summary stuff, then it filter all symbols again, I guess. Fetch dot symbols by volume, you filter, combine this and that, and you return final. So maybe, so the market summary, we want it to be 48 hours, but the filtered symbols we also want to be 48 hours. So there's no need to have. So we need to cache this thing too, because otherwise it doesn't make a lot of sense. So let's see if we manage to cache this thing. So we have already cached the exchange get market summary. So I'm not sure if we are going to be able to do the same thing here. So it's something like this. So at the very top we have the filter symbols. Okay, so here at the very top we have the market summary cached. Market summary cache. Yeah, what's the name? Filtered symbols? Okay, let me open symbols down here. And so filter symbols by age and volume. Okay, so so this my age, volume, filtered symbols cache. So we have the that and the timestamp, and this is the same thing with a timeout, which is also going to be 48 hours, because the data is 48 hours. So that's what we're going to be using. So then we need to take a look at BTSE, which is using all of this. So we have a preon function which we are going to replicate here first of all. So this is going to be preon age volume filtered symbols cache. So if the cache timestamp is known, you return. If this and that, whatever, you do this and you do this, and then we have the timeout, which is here. And then we have this thing here, which is you prune everything, and then if you have that data, you do whatever. So let me see. You prune everything, which we are going to do with the proper function names. So we prune everything, and then depending on cache value, we return one thing or the other. So BTSE. Then what happens here, if we don't return, is that we want to be saving whatever thing we are about to return, which is the data. So we actually return final. So the idea here would be, let me see, do we return? Yeah, so the final thing here should be something like this. So just before returning everything, we say, okay, let's save the data here and let's make a timestamp. But the different thing is that the name is different. So the cache is called like this. So data and this thing. So we're going to save the timestamp and the data, which is final, which is the final whatever this is, filter H by H and volume, which in the end it's going to be the cache data, which we save here on the very top. I mean, we save it here, final, which is what we return if we save it, but if we have already saved it, we just return it here. We just check for data, which is what it's saved into here. So this only prunes everything if either we if we have some data here, and if this is like this, then we also encourage to get the data. So we should be fine with this thing here. So we managed to cache this thing too, which is make sure to cache age and volume filtered symbols. That's what we do here. Okay, so if we do that 48 hours, this is going to go fast. Not the first one, but the next one it's going to go fast. And that's going to be very nice, if you ask me. Okay, what else do we need to do? Let's go to main.py. So we have managed to avoid init the known symbols database. So we are no longer reading or writing to the database if we had already done that. We are fetching the market summary. This is cached. This was already cached, but now we know that we can go 48 hours with the same information. There's no need to check for new symbols every hour. We can wait 2 days. In any case, we want like 1 week of a symbol to be old in order to trade it, so that's expected to us. Then we filter the symbols by age and volume, and this is going to be cached, which was not cached before. So update symbol registry filtered symbols. So each time we do a new cycle, we are updating the symbol registry. So let's see what the hell is this. If let's see if this makes sense to be cached or not. So update symbol registry. It's going to be in trading symbols. So trading symbols. Trading symbols. Okay. Let's search for this. Update symbol registry. So this is opening the database, is getting the symbols, and if they don't exist, we put them inside of the database. So I think this is something that we can do. Filtered symbols. I think we can cache this thing instead of writing again and again. So how to do this? So it will be the same thing. So if we have already cached this, then you do the stuff. Like instead of returning, you do all of this. Otherwise, you return. So I think that yes, that I mean no. So I need to. I'm going to open a conversation with this thing. Setup symbol modes should also be the same thing. Okay, let's open a conversation with Google Gemini and see how well it goes, because I'm not sure this is going to work as expected. So this is a Python symbol. Can we use apparently 22? According to this, we should already have this thing. Let me update this thing. Okay, so we have the pro stuff in here. We can use it. So new conversation. Let's do the pro one. So that. Okay, so let me see. Python. Rewrite so that it uses a global variable named state dot symbol registry cache in order to know if there were any changes into calls. If there were no changes, there is no need to make the main code from the function we just return, because we already done that. So the variable will be set by default to empty. I'm not sure. Filter symbols by age and volume. I think symbols by, is it like here, filtered symbols? Filter symbols by age and volume. So I think that the idea is this one here. So what I'm going to say is that we'll default to this thing, so that the first time it does what it needs to do. Okay, hopefully this works as expected. Here's the updated function. I have a even you pass a tuple generator. We store a copy. Okay. Ensure the cache exists on the state object if not already. We are not going to do this thing because we know that it's going to work. And then current symbols, list symbols. Okay, so if the symbols are identical to the last call, then return. Otherwise, you get current symbols. And then here, no. We actually want to be using symbols, which is what we were having before. So I don't want. I'm okay on having this thing, but not like this. So let's copy all of this and try to fix it. So I don't remember update symbol registry. Update symbol registry. Here it is. So let's put the original one down, and we will try copy and paste everything and see what happens. So the only thing I want to change, let me open down here symbols again. So 58 or whatever. So what I have down here is the old function, and here on the top is the new one. So what I want to make sure is that I'm doing exactly the same thing. So console. So instead of current symbols, I'm going to use symbols, which is what I did before. So this should be exactly the same thing, which I think it is. New symbol, status new, execute, whatever, sim new, commit and close. But I like this thing like current symbols, you convert into a list, because whatever. So if it's the same thing, then you return, otherwise you update the cache. And so I need to check if this makes sense or not. But more or less this is what I want to be doing here. This thing here, we need to initialize it here. So state, symbol registry cache, it's like this. And as we are importing everything, we should be fine. There's no need to have this import here. So if we take a look at what we have here, we want to add a state and symbols. So this is going to be again cache Update symbol registry step. Skip updates skip the when not needed. When it's not needed. Okay. When it is not needed. Nice. So, my question is this thing here. Oh, look at that. I can copy and paste. There's no thing. Regarding your proposed, this wouldn't work in Java because the objects would be compared by reference. Does Python compare each one of the stored symbols individually? Elucidate the list equality. Yes, in Python the equality checks value equality, not reference. Unlike Java, what okay performs does okay. If the symbols inside of your list are strings, which is the standard for symbols, this works perfectly because Python strings also compare by value. Important note on deep equality. Performs this recursively. If your symbols are... Okay. I have no idea if the symbols... Yeah, I think that the symbols are strings, so we should be fine. Okay, wait a minute. How the hell have I saved in here, isn't it? Nothing. Yeah, I need to add this other file and amend. Yeah, that makes sense. Okay, so I like this thing a lot because if this goes as fast as I think, this is going to be instant. And yeah. What else do we have here? Update symbol registry. Set up symbols mode. This should work the same way. Mockup. What? Get only ready symbols for trading. Get ready symbols. This is going to be the same thing. We're going to cache them for 24 hours. So set up symbols mode. Yeah, we have a lot of stuff. I mean, I don't know how long did it take all of this, but filter symbols by rank. Easy 10. Yeah, this is the important thing that we have already optimized somehow. Let's work with setup symbols mode and see how we can optimize this thing here. Because if this goes fast, we can do something. Why do I have 4? Wait a minute. That's not... I don't expect... Okay, so apparently OBS takes a lot of CPU. Anyways, so setup symbols mode. Yeah, trading symbols. So let's take a look at trading symbols, which is here. So look at that. So we get from the database, we get new symbols, and then we update them if there is a need. Get new symbols. Get ready symbols, base symbols. Yeah, maybe we can do something with filter symbols or whatever, because maybe we can put the logic here. I'm not sure. Let me see. So first of all, we cached market summary. This is going to return always the same thing. Then we filter symbols by H and volume. Then we update the symbols registry in the database. We set up symbols mode so that they work as expected. And finally, we get the base symbols based on these ready symbols. Which is going to read again from the database. And we also have this thing about have we in the database or not in the first place, which this makes sense. You only do this once, but then all of this market summary thing should be we should be maybe, if it's only used here in order to get the filter symbols, update the symbol registry, set up symbols mode, base symbols, and then you return the base symbols which are already filtered and so on. This should be going into a method that catches all of this, and that way there's no need of doing this. So we only cache this thing once, and then we do all of this if needed. So what we actually want is to get the base symbols only once and forget about them. But in such a case, we need to refactor again. So let's see. So here we have the initialized known symbols db1s, which we have done here, which makes sense. Then the market summary expires in 48 hours, and same thing happens with the H and volume filter symbols, and we update the symbol registry when it's not needed. So I think this is the only one that we need to keep. So from here we're going to create more trades 6, and from there we're going to work on something else. So all of this is get me the base symbols. You know what I mean? Get me the base symbols. So this is another method which it's going to have the base symbols, and we're going to cache them. Okay, wait a minute please. Okay, so yeah, so the idea is to put this into a method, then we just return the symbols, which is I don't know. Base symbols are so known symbols db, which I guess is this thing here, and we ask for get ready symbols. We just return whatever. So let's create a new conversation. What empty result if this was an empty result, what would that be? Something else. Okay, so let me see. I'm not sure. Yeah, I'm using Pro, but yeah, pinpointing result empty list, because return empty list, lead comprehension will not be. Okay, so it's an empty list. So basically, yeah, so basically the base symbols should be an empty list. So yeah, okay, so let's make a method somewhere in main.py which does this thing like main.py. Okay, I have found it, it's here. So let's create a new function, not sure where to put it, maybe here. So this is going like get base symbols. I mean, it's not a very good method, but yeah. So get base symbols, it's going to be all of this. So basically I want to have this thing here, so I copy this thing here, and this is what it's going to be doing. So we need to have some variables here that they are needed. So like market summary is no longer needed, filtered symbols it's no longer needed, this thing I don't need it, known symbols db it's imported. So yeah, so basically I think that I don't need to do anything else. It's just get base symbols, which so basically what we do is we return base symbols in here, and we just call get base symbols down here the same way we call other functions here and there. So we do this thing here. So wait a minute, please. Okay, so now we have the new method that we can just base symbols equals, so base symbols, wait a minute, base symbols equals get base symbols. And we just remove everything here, and then we can just play with what we already know regarding all this cache stuff that we like so much. So we had some examples of how to do the cache stuff. So this should work, this should work as expected without doing anything else. So what we're going to do is we're going to work with the get base symbols down here, with the get base symbols function, which is going to work similarly to the BTSE one regarding the market cache summary. So let's do this thing. Oh, look at that. This is 5 minutes instead of 48 hours, but we don't care because we are not going to ask for the market summary until 48 hours have elapsed. So this should not be a problem anymore. So we don't care the market summary cache, so it's like you don't need to test that in the first place. So we need to have some variables around here. Oh, look at that, market summary cache. Why the hell is the market? Wait a minute, have I copied this thing? What the hell? Look at that, market summary cache. Why the hell is this thing here? Market cache summary. Yeah. What the hell? What the hell? What the hell? Okay, so I mean, I actually want to have this thing, but at the same time I need to remove it because it doesn't make any sense. But it's like I had to copy and paste this thing here. So I don't know. Let's remove this thing first of all, and then let's try to work. So okay, so this thing here, remove all non-use code. So now we have get base symbols and this thing, and we're going to edit back whatever what was here because it's useful for us. But this is going to be used to be called base symbols cache. Base symbols cache. So this is going to be base symbols cache. Here it is, and this is going to be 48 hours because I say so. So base symbols cache. So we just modify all of that, Also, we have a timeout. And yeah, so this is going to be prion base symbols cache, which is a function that should be just above the get base symbols, which is what makes sense. So the same thing we did before, we just prune these values the first thing when we are here. So we prune the base symbols cache value. Okay, and yeah. Prune base symbols cache. Then later on we need to do this check here, which is what happens if there's something to be returned, then we return it. So this is not the bucket summary cache, but something else which we return. Okay, and then before saving the stuff, we save it. So that's what we are going to do here. Just before returning the base symbols, that's where we're going to cache it. So we use the right variable names here, so base symbols cache here and there, and the data that we are saving here is the one that we return, so this one here. So now we have a 48 hours base symbols cache, which is going to be a very nice thing to have, if you ask me. So let's save this improvement, please. Wait a minute. Why? Start new cycle. Start new cycle. Yeah, somehow it does not detect. I mean, we are removing so much stuff that it does not detect what we are doing in here. Filtered symbols, low volatility symbols, resume. Cache fresh data with current timestamp. Base symbols. Start new cycle. It's interesting how it does not detect this as we expect it to be, but yeah, we are changing a lot of stuff at the same time, so I guess that makes sense. So make sure to cache base symbols. Okay, wait a moment, please. Okay, so what I want also to be doing once we cache these base symbols is to I don't know, not to trade if it's the first time we do the loop. But how would I do that? Handle case where no symbols are selected. So start new cycle. Okay, so start new cycle has how the hell do we do this? So first of all, either we resume or we do the other thing, which is this thing here. Okay, so you get the base symbols, you do whatever, you go here, you ask for a least low volatility symbol. So we do another filter. Maybe we can cache this thing or just avoid asking it altogether. So this is on trading trend. Trading trend. Trend. So we are asking for a low volatility symbol. Determine whether a symbol is low volatility based on body shadow ratio using a trim exponential weighted mean, whatever. Yeah. For symbol in base symbols, low volatility symbols. Yeah. This is bullshit. We don't want to do this. There's no need to do this every time we loop. Forget about all trades if we are starting a new cycle. So this is done with base symbols. Okay, anyway, so here we are checking the low volatility symbols. Which we don't cache, and we should be caching, if you ask me. So we should be having another function which is get low volatility symbols, where I just give you base symbols. Yeah, that's what we are going to do here. If it's low volatility and then volatility metric, are we actually using this somewhere? No, we don't, but we are having it just in case we need to do something with it, I guess. So is low volatility symbols. Okay, so let me check. We're going to cache this thing because we are checking if this is a low volatility symbol, which, you know, maybe yes, maybe not. So main.py, get base symbols. So this is going to be get low volatility symbols. So get low volatility symbols. Here it is. Get low volatility symbols. Prion low volatility symbols. And then return low volatility symbols somehow. And I guess that we can do something like low volatility symbols cache. Which we are also going to use in here. Bring low volatility, whatever. So so it's not very complex what this is doing here. So wait a minute. So each time there's a loop, the low volatility symbols is empty. So maybe that's the way we should be working with this. Yeah. So this should be the function. So low volatility functions is get low volatility symbols. But we are missing the argument, which is base symbols, which we are going to input here. So base symbols here. So this is the main code that we want to replicate in the in here. So we want to be removing everything but this and this way. So for symbol in base symbol, then define these two things, and if this is true, then low volatility symbols, which we are going to define as empty here, get something added and we return it. Yeah, look at that, we return it. So we are this needs to be down here, I guess. Let me check real quick. Yeah, so we return the empty or the whatever thing in here, and if there's any data, we just return it. And we need to just copy and paste the prion method too, so that we use it. So prion low volatility whatever cache. So now we have the symbols cache thing into here, 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 and here. And this one is the timeout one, which we are going to set somewhere on the top of the file, which is here, I guess. So it's also going to be 48 hours, so I guess we should be fine with that. So maybe we are missing one in more days, but I don't care if it takes 4 days to. So low volatility data is returned if this is not known, none, and if this is known, you return anything. So that whatever. Yeah, we are doing what we know how to do. And this is base symbols. No, this is not base symbols. You actually want to be returning low volatility symbols. So this is what you save as data. Yeah. So this thing here can be removed. So my question is, why do I define this as empty here if I'm already defined it here? Don't know, maybe so that this is empty and we don't have any problem there. I don't know. Hit diff. Low volatility, whatever, prune, get low volatility, get low volatility, base symbols, get low. Okay, I think we are done. So the question is, should we maybe do this in only one function? I don't think so. So this is like cache low volatility symbols. So when you go here and you work with the low volatility symbols, these are cached. So that now that you go into filter symbols rank, you don't have. So filter symbols by rank, it's also going to cache low volatility symbols. It's also going to cache, you know, something else. So I wonder if we can just remove this thing, low volatility symbols. I mean, but we are caching them, and so when we filter symbols by rank, we are going to remove that symbols which we can cache 48 hours. If I'm right. So this, we can find this in trend. So we go in trend and calculate easy whatever, which is here. This is where we reject all of the dead stuff, and yeah, so if the choppiness is whatever. Wait a minute. If the symbol is stagnant, we reject. But the thing is that a symbol is stagnant. This is using under the hood. I mean, this is using under the hood something that cached the result, so that a symbol stagnant is using under the hood something else, isn't it? So this is doing an stagnation score, which if you check in here, you can see how we have an stagnation chart cache, which is going to save regarding the symbol, the last refresh and whatever, and this is used in order to know if we need to do a force refresh due or not. Okay, so yeah. Okay, in any case, no valid symbols found, skipping cycle, and then you do another one. So what I want to be doing here is I want to have this defined to a state known or something like that, or the first run or whatever. And then if we go here, that we have everything into place, we can just return known, and then we go on and we decide to do something else. If not, resume. I mean, here we have contract sizes, mean price incremented, and whatever, which we are doing with all of the symbols. Now that I see this thing, but in any case, So here we filter the whatever. We do the API cache fetch of all of this. Contract sizes. Wait a minute. This needs something else, like how long do we need to cache this thing? So this is defined, this function is defined in client cache. Client cache. So look at that. We are asking this function to whatever, and we are getting a reply. So so it doesn't make sense to ask for this. So I know that this is going to be using fetch contract sizes from whatever, from BTSE exchange, you know what I mean? So exchange BTSE cache, I guess. BTSE cache. So from exchange import BTSE. So we have all of this stuff in here. So fetch contract sizes, which, yeah, it's going to actually do the, wait a minute. Fetch contract sizes from BTSE. Fetch contract sizes. Let me see. How the hell does this work? So we have fetch contract sizes. So we have a throttle whatever. So first of all, we are asking this for all of the symbols, which is a lot of stuff, but you know, I don't care too much, I guess. And then we have this thing about compute contracts from price, symbols and so on. So you can see the contract sizes, contract map. Then you classify trend of range of the symbols. Wait a minute. Okay, because this is when you filter symbols by rank. You are not working with all of the symbols, but just the filtered ones. Okay, yeah, so this makes sense. We are not doing everything, we are just working with the filtered ones. Okay, nice, nice, nice. The thing is that we are doing this API cache fetch thing, which, I don't know, API cache fetch. It's defined in client.cache, but it's not doing anything that makes sense to me. So this is calling to the APA daemon, that's true, and then it asks for doing this thing. And in theory, if you take a look at the APA daemon thing, it's supposed to be checking whatever. So if it's cached of whatever, it's going to do a cache manager, which is something that I guess has some kind of cache. Do we have a cache manager? Daemon.cache. Okay, so daemon.cache. Request delay. So there's this cache TTL which is 300. So when you get something from these values here, you get 5 minutes cache TTL. So it means that if you don't have 5 minutes, if this is not 5 minutes, then you don't do it. And then contract prices, so max expected lows, weight of, okay. Anyways, so what I'm seeing here is that this API cache fetch, the only thing that it does is that it waits for 5 minutes in order to get the contract sizes and the mean price thing. So I'm not sure if this is used somewhere else, because maybe it's not the best thing to be using. So look at that. API cache fetch, it's 5 minutes. This is not right. Okay, let me write this down just in case I have to end stream sooner than later. So I guess today is 23. That's right. Make sure to cache for 24 hours these 2 lines. This is from main.py, I guess. Because there's no need to have more than this. Okay, so the other problem that I have is that I have is this one here. Like, check for the hours. Maybe we can do it like this. The other problem that I have is that this is using this thing which under the hood uses API cache fetch, which would use daemon cache.py, which seems to have a cache TTL of 300 seconds. We do not want that for 1 minute data, and I'm not sure about 5 minute data either. Yeah. So when you do a function name and an argument, you do a cache TTL of 300 So this is used when you get the function to know if you have to return it or not. You know what I mean? And yeah. So we should be able to override that TTL so that it uses just 1 minute if we are querying for 1 minute data, because otherwise we're getting all data and we want to have the exact data here. So yeah, I'll be back in 2 minutes. Please wait. Okay, so I'm back. Let's write here. I'm back. So we were saying that we want to cache the contract sizes and the mean price increments, because why would you ask for the contract prices sizes again? Why would you ask for the fetch minimum price increments? So if this is something that we're going to do every 2 minutes or whatever, we don't want to ask for these values again and again. We just want to cache this thing for 48 hours the same way we cache everything else. Yeah. So, and then there's this thing about a Pikachu fetch. When you get the 5 minutes and when you get the 1 minute, the 5 minutes is okay, but the 1 minute it's caching, it's actually caching 5 minutes. So if the current price is based on 1 minute, maybe we don't want to do this. Maybe we want to be maybe we don't want to do 5 minutes. So so this is like doubt. So the doubt is getting current price versus knowing if a coin is dead or not. We wouldn't mind a 5-minute delay for that. Yeah, so maybe there's no need to try to enforce a TTL of 1 minute if this fetch 1 minute is only used for is dead or whatever thing that we might have. So in any case, I would like to you know, just work with this thing about fetch contract sizes and fetch minimum price increments thing that I think we need to cache, and that way we do not need to, you know, to ask for them each time. So this should be quite similar to what we have done before, which is contract sizes and min price increments thing. So maybe yeah, to have here like a get method, and that's it. Then later on we will see compute contract prices. I mean, actually, max expected loss is this thing here. So maybe contract sizes, min price increments. Wait a second. Yeah, this is used later on somewhere else in the code, if I'm not mistaken, in order to know how much, you know, it's used the range, then in the order, in order to know how much it has to use of whatever. So yeah, so this needs to be so we're going to have this let me see. I mean, these symbols are based on whatever is here, so 48 hours thing. Let's create these get functions, and that's it, because that's what we do. So let's create the get functions, one for this, one for that, and yeah. So we have one bookmark here so that we know what we are doing, and in main.py we have another bookmark here. So it's like we want to recreate all of these, the low volatility things. So let's start with the first function, which is get contract sizes. Okay, so get contract sizes, so from 260 whatever, low volatility symbols. This is going to be contract sizes. Let's go. So prune and yeah, not sure how this is supposed to be working. So this is more or less what we want to be doing. So we also need a cache for all of this. So this is going to be like, let me see, low volatility symbols. Damn it, I have not done this properly. This is contract sizes. Damn it. Okay, so maybe something like this. Low volatility. Okay, so now this low volatility symbols thing should be contract sizes. So let me just replace all of this as expected. Yeah, I haven't fixed this one here. Get contract sizes. So symbols. Wait a minute. So prune contract sizes cache. If contract sizes cache is known, return. Okay, return what? Yeah, return and then do whatever. Yeah. So what the hell have we done in here? So let me just undo here a lot of stuff because I'm not sure what the hell did we do here. Hit diff. Okay, so again we're going to do this thing like 48 hours, then each 48 hours we will have a long trade that won't be so good, I guess. So we probably want to do it later on, so that, I don't know, so that it's not so bad. But I'm not sure about that, so we will see. So again, we want to copy and paste all of this. And then just low volatility current sizes. What's wrong here? Do I have any space? Yeah, that's what is wrong there. Okay. Let's try again. So we have a space which I'm going to remove. Now this makes sense. Okay, so replace and replace, and maybe we can just copy and paste this thing and just also replace this thing. So now we have where the hell is this? That we have contract sizes cache timeout 48 hours, which is very nice. So let's go back to what we were doing in here. So low volatility symbols should also be replaced with contract sizes. So let's do this. I mean, actually you want to be checking what the hell does the function, but other than that, yeah. Print contract sizes could change. Okay, so I guess that this makes sense, and I guess that this makes sense. So contract sizes, you actually want to be to have symbols as an argument. So that's what we're going to be using in here. So basically what we're going to do is to replace our old line with a new one, and this is what we want to be returning actually in here. So it's something like this: contract sizes is whatever, and then I return contract sizes and I save it. But if this is not, if it's not known, then I return, and this only happens when we print the stuff. So we should be fine with this. Let me remove this thing. So we can remove this app-cache fetch because we already are doing it somewhere else. And that's it. So now we need to do the same thing with mean price increments. And we will see what the hell we do with compute contracts from prices, which I do not want to do, I guess, or maybe yes, I don't know. Do we want to cache that? I don't know. So let's cache this thing. So cache contract sizes for 48 hours. Look at that. So we're going to do the same thing with mean price increments. So it should not be as difficult. So it's just find and replace. So now you are here 282. So contract sizes, and this is going to be mean price increments. Okay. Yeah, we are doing this thing. And again, we want to be replacing this with the capital letter ones, so mean price increments. Yeah, let's do it. This is the place where I'm going to do the call, but later on we should have this thing here. So okay, so we have replaced it with mean price increments, and in here we should be doing the same thing we did here, which actually is the same thing, which is fetch mean price increments. It's the same thing. So this is saved into here, mean price increments, save into data, whatever, you return the mean price increments. You know what I mean? And the mean price increments. That's very, very nice. So get mean price increments. Yeah, it seems like it makes sense. So basically what we're going to do here is get mean price increments. Wait a minute here, and symbols. So we have the cache, and this should be working with the cache in a very, very nice way. I mean, actually we could try to do this like a class or something, that so that it's done in a nice way or whatever, but right now this is the way we do it. Yeah, so let's save all of these changes here. Cache mean price increments for 48 hours. So look at that. So if contract sizes are cached for 48 hours and symbols are also cached for 48 hours, I mean, symbols are not cached. Wait a minute. Wait a fucking minute. This is not working as expected. So I can cache contract sizes for 48 hours. Wait a moment. This is not right. So the problem that I have is that, I mean, it makes sense to cache what we were caching right now, which is base symbols. So base symbols, which is defined here, we get base symbols. This is based on fetching the market summary, which is everything. Then we filter symbols by age and volume and so on, and we return the base symbols, which are always the same ones. Okay, that makes sense. So in each one of the loops we get the same base symbols, so we are fine. We don't care, you know what I mean? The problem is that um, when these base symbols are passed in the get low volatility symbols, yeah, we also cache this for 48 hours. But the problem is that filter symbols by rank, which is going to be using EC10, okay, to know if we have to trade or not, this is going to return symbols. And these symbols here is the one that we are going to use here in order to get the contract prices, mean price increments, and so on. You know what I mean? So all of this in order to say that what we have to cache for 48 hours, it's the contract sizes for a given symbol, not for a not for every one of them, because you don't know how many of them you will have in each one of the loops. So you might have always the same symbols regarding EC10, but maybe not. So this needs to be thought better than what we were doing before. So currently, if we take a look at more trade 6, we are catching the mean price increment, the contract sizes, the low volatility. So these two ones we don't need to cache. I mean, we want to cache it, but not the way we are doing it. So we need something better than what we are already doing. So we need to fork from here, from the low volatility symbols. So this is going to be more trade 7. Yeah. Okay, so now it's going to say something like it needs to be. Okay, let's take a look. Okay, we have the old code, apicache fetch, so it has been refreshed. So we have already cached this thing with something else, so which is the symbols. So let's see how this is done with the different symbols, and that way it will be better in order to do it. Apicache symbols, fetch contract sizes of this. So we are supposed to have a fetch contract sizes symbols that return the contract sizes for the symbols, which is all of this. Yeah, we do not want to do this thing. I mean, we want to do only one of them. If it makes sense. Okay, so maybe we should talk with Google Gemini and see what we come out with it, because otherwise I don't know. So I have this line of code in main.py file, which uses damn it. Which uses fetch contract sizes method. Under the hood. The problem that I have is that I want to cache for 48 hours each one of the symbols contract sizes. Let me see. Have I do it in here? Minute. What the hell? Why? What the hell? I don't understand anything. Are you telling me that minutes 55 was always like that? What? Hit blame. Hit blame. What? I'm not sure what I'm blaming. Exchange BTSE .pi. Where's the 5-minute thing? Where's the line for this? 66. So line 66. What the hell is this? Why? Okay, now it makes sense. So, okay, so I can save this thing like this. Wait, minutes equals 5. And if I run hit diff again, we should be fine. Okay, let's try again and see. So I already have the symbol cache somewhere that I don't remember very well. Maybe fetch one thing. Okay. Maybe you can get the idea on how to cache this based on symbol thanks to this other code. So the code is to fetch 1 minute symbol, which is like this, and then the YouTube simply 1 minute cache thing is like in here. So this is the prune one, and then we need to have the cache and the cache timeout. Which is this thing here. this. Please, no, please, just please do not modify method. Just create a new one that only works with one symbol and calls this original method, converting the symbol into a list or a dict, whatever it makes more sense. Yeah, hopefully this makes sense and it does what I have asked it to do. Here's implementation of a cache variable for a single symbol following the logic instead of existing to do. This solution creates a fetch contract size cache function that handles the 48-hour timeout. Runs calls the original method for wrapping a single symbol in a list. Okay, let me see. So we have a contract size cache timeout. We prune it. So we remove the expired keys. Okay. And then it do the maintenance. If it's in here, you return it. Okay. If it's not the case, then you fetch the contract with like this. So the result dict. Okay, contract size from here. And then you contract size symbol. We save it. So contract size and whatever, and you return. Okay, it's doing this thing in one go instead of two, but I guess it's is the way to do. So in the main program that we have this thing, we can do size fetch contract size cached. Yeah, but I don't want to do that. Or do I? I like this thing a lot. The state dot contract sizes. Okay, so this function here. So let me see how do we implement all of this. So we need another function here, which is this one here. Print contract size cached, and this should be on the top. So on the top places where all the cache is defined, so we do it here. Contract size cache and contract size timeout. Okay. And so down here, so the question is, if we go into main.py, the very first lines, do we have everything that we need? So we have date time, we have time delta from date time, that's okay. and then from decimal we import decimal, so there's no need to have those extra lines, we already have them. Nice. So prune contract size, and yeah, I wonder if we need so many comments in here. So fetch contract size symbol. So once we have all of this, we also want to implement, we want to do this thing, state contract sizes and whatever. From the main program, which is in here. So basically this is like that. So update contract sizes. So I wonder if the what's the name? I wonder if the method that we are using to get everything, which is fetch contract sizes. Yeah. So my question is this filtering? So this is from BTSE. So fetch contract sizes. Okay, for each one of them it tries to do a request, so it's the same thing as you know, we should be good with this. Okay, so let's fix this small stuff regarding spaces at the very end, and we should be fine. So result tick. Okay, so now we have all of this. So update contract sizes. So this is going to be cache contract sizes per symbol per 48 hours. So I think that again 48 hours should be the thing that we actually do, and we should be fine with it. So now I want to be doing the same thing, but with this thing. Hopefully do the exact same thing, but with line. So it should create whatever. So hopefully it makes sense. So min price cache, prune whatever, fetch min price. So it's wrapped into list because the original one do this thing or this other thing, min increment this thing, return, otherwise you prune. Yeah. and then you just replace this thing. That's what I actually wanted here. So that's very, very nice. So first of all, let's go to with, so here we don't have any change, isn't it? So first of all, let's go with the first code, which is this one here. So how we do all of this. So we don't need date time and date time delta because we know that we already have them. And this thing here should be on the top as we did before. So let me find these values here on the top, and we will see how it goes. Mean price, cache, mean price, cache, and timeout, whatever. Yeah, look at that. So the next thing we want to do is to use it, and we should also have an example on how to use it, which is this one here. So in here we should have update mean price increments. I mean, this should be a method, but I don't think we need a helper. But this is what you want to be having here. So it should be like get contract sizes instead of fetch contract sizes, but so get contract sizes, and it should be doing this thing here. Yeah. Okay. So we need to remove this, isn't it? Nice. Okay, look at that. Let's fix this. So brim mean cache. Wait a minute. Expired. Having a hard time to find what I want to be removing. So this one here and this one here. Yeah, so once we do that, we should be able to work with all of this. Look at that. Mean price cache. Yeah, look at that. So hit add main.py, and this is going to be like mean price increments. Cache mean price increments per symbol per 48 hours. Okay, so once we have all of this, we need to make sure to see what the hell happens with compute contracts from prices. Okay. So compute contracts from prices. It's doing something that I need to take a look at, because it's using symbols as an argument, you know what I mean? But haha, it's using compute contract price. Oh, wait a minute, should we remove this? Because what happens if the symbols, if we have less symbols but we are still trading, we should not be trading news. We shouldn't be trading. We only trade when a new cycle happens. So this should not be a problem. So compute contracts from prices. Let's see what the hell does this, because I want to cache this thing too to see. So trading common, that's the thing. So yeah, trading common is in here. Compute contracts from prices. So we have symbols and we have contract sizes. Contract sizes is going to be always the same. It might be the same 48 hours staff, and symbols might also be the same 48 hours staff. But once you have the symbol and contract sizes, wait a minute. I'm not sure how we are going to do this. So let me just copy this thing and let's ask Gemini to do this. Please explain to me what this method does. Look at that. Analyzing the function's logic, whatever and whatever. Balancing risk indirectly. This method is a risk-balanced position sizing algorithm. Its primary goal is to distribute your available capital across different crypto assets, not by equal dollar amount, but by equal risk. It tries to ensure that if any single position hits its stop loss, the financial hit to your account is roughly the same as any other position. Okay, so here's a step-by-step breakdown of what the code does. Data preparation and risk calculation. The code first iterates through every symbol in your list to calculate the cost of risk for a single contract. So if it iterates every symbol, depending on them being cached or not, it won't. Okay, so then it fetches price. Get the current market price from this change. Oh my god. What the hell are you telling to me? Get current price. What I'm supposed to be doing here? Okay, so compute contract size is using common contract is using get current price. We need to know if this is cached or not, and if we want it to be cached or not. You know what I mean? In any case, let me push the current work right now, because otherwise we might forget about it. Let me edit the video. So this is going to be more trades 7. So part 18 is going to be cache a lot of things to speed up the script. Okay, so if we go back here, yeah, I guess. Okay, let me put the URL somewhere else. So small trade 7. Do we have any of that somewhere? I don't know. Maybe. I'm not sign up. Okay, so more trade 7. Let's copy this on the chat just in case someone doesn't know how to read the you know, doesn't know how to read the video description, so you have it in the chat. So this is querying the get current price for the symbols. So I want this to be cached because later on we are going to trade, assuming we have this get current price. So yeah, so let's keep reading what the hell does this function. So data preparation and risk calculation. So it iterates through every symbols in your release to calculate the cost of risk for a single contract. So first of all, it fetches the price from the current market price, then calculates the notional, which is the price times contract size. Then it calculates the risk per contract. So like trailing stop percentage 1%. So how many money would you lose? Okay, and then there's this budget setup, like you want to only spend 80%, and then you do the water filling allocation loop where it keeps filling it up, which is, look at that, find this thing, then you buy, add one contract, repeat. This naturally fills up the position sizes. A volatile asset will stop getting to style assets, output and login. It calculates max expected loss, the highest single position loss exposure in the portfolio. It logs the total stats for every symbol: price, contract count, total notional value, total expected loss. Returns a dictionary mapping symbols to contract count, so BTC2, ETC, ETH 15, and whatever. Potential issue to watch. The logic initializes every symbol with one contract. The risk: if you have a very small account and one of the symbols has a very high minimum contract value, for example 1 full BTC, the initial setup might exceed your budget immediately or result in an imbalanced portfolio because it must hold at least one of everything. I think I already take care of this, but maybe he's right. So we start with one contract, but if it's more than it, we do not do it. I don't know. Okay, so what happens here is that this is using symbols which we have cached previously. So when you are here in the main program and you do this computer stuff, you're using symbols which we have worked with them previously in here, and then we use contract sizes. So contract sizes it's also something that somehow it's cached for 48 hours. I don't know if I'm doing this right or not. So we have like contract sizes is going to be a very big array because we do not remove all of the symbols, we just remove the ones that we have. So we have old symbols and new symbols, and so if we remove symbols, so I guess we should be fine. So this is contract sizes is cached in all of this, and symbols is cached in all of this. The only thing that changes when we work in here, the only thing that changes is that you get the current price for the symbol, and given the current price, you do some stuff in here in order to decide how much is this or that. So this is not a thing that we can cache, if you ask me, unless it's less than 1 minute or whatever. So in any case, get current price, this is the thing that we might want to be looking at. So later on when we run this thing, not resume, whatever, this thing here, classify, trend or range. So classify, trend or range. Okay, so it's a trend or not. So wait a minute. If not resume, my question is, what the hell does this thing? Because classify, trend or range, I mean, I can understand this thing, but at the same time, trend type. Aren't we asking if this is a trend or a range a lot of times? Why so? I'm not sure about this. So classify, trend or range. It's also being used in I mean, it's been defined in trading trend. So let's take a look at trend if you want to. So trend.bi. I mean, it's very useful in order to determine. Okay, let's do this like this. So classify, trend or range. So look at that. And do we have a cache for this? Really? Why? So we have a cache for this, which do the actual classify, trend or range real, which I'm going to check right now. But in any case, which is the timeout for this? The hell? Where the hell is this? State. Okay. So I'm not sure I'm going to get this thing from here, but maybe here in the main branch. 5 minutes. Oh, look at that. Trend range cache. 5 minutes. We actually want this to be 1 minute. Because... or not. No, we don't want. 5 minutes is okay for us. But in any case, this is using a functions from somewhere, which is here, classify trend or range real, which is doing calculate easy trend 10 with RSI for this, and depending on the result, it's going to say that this is a range or whatever. But this is using calculate easy trend 10 with RSI method, which I guess we are using anyway. So this is like, let me see, classify trend or range. Is using, which uses so this is from trend.pi. Trend. So trend classify trend of range is using classify trend or range real, which uses calculate easy trend 10 with RSI. Okay, look at that. Calculate easy trend 10 with RSI. Which we might have been using right a few minutes earlier in somewhere else, which is, so this is a classified trend or range, which we only use to say, okay, this is something or not. I mean, it's used later on in order to determine if we want to trend or not, isn't it? I mean, because here we're going to do the update train and stop loss and place all positions thing, which maybe uses this thing here. But the problem that I have is that filter symbols by rank 10, it's already doing this thing, and that's which would use EC10, which uses thanks to the EC10 parameter. Okay, look at that. Thanks to the EC10 parameter. What do I know about this? So Let me see. So basically what we have here is that when we go to main.py, I can do this on the right, because otherwise, when we go to main.py, we do the filter symbols by rank, which is going to use this thing. And so we don't want to be doing the same thing again, if you ask me. Even if it's just, you know, computer stuff, we don't want to do that. We just want to just use whatever it has done, and that's it. So look at that. Filter symbols by rank. It's being used in trading symbols.py. So filter symbols by rank. It's like long top number. This is 3 and 3, but usually it's 5 and 5. By default is EC8, but we are using EC10. So basically what happens here is that if we use EC10, it's going to use the calculate EC trend 10 with RSI. Trend score symbols, TMP. Normalized trends result. So as you can see here, we're doing some stuff in here. Maybe we can try to use it somewhere else. So we were saying that trend classify trend range is using this thing, which uses this thing in order to get a score. So classify trend or range real. So hopefully so we do this like 5 minutes. Classify trend or range real. So basically what happens here is that the result is cached. We want to cache this result because we already are getting it, isn't it? I mean, the look back might be different because look back here, look back is 50. And here is whatever, this is by default, which I don't know how much is it, if you ask me. It's 52. So somehow we need to detect when there's a cache or not, and return that, because that way we avoid having to compute the same thing again. I mean, all of this should have a cache of, I mean, 1 minute, 2 minutes, I don't care, but it should have a cache given one symbol and all of these parameters. because this is used in here. Okay, but then I mean here you have normalized trend result, and then you can get the score. But here on the main.py we are filtering symbols by rank, which we will yeah, it's this one here, isn't it? Filter symbols by rank. Yeah, so we want to cache this thing so that when the main.py is running this thing regarding you classify this as trend range, which I guess is used later on. I think this is used later on in order to decide if you trade or not. So this is used in orders.py. So in orders.py, which is here. So when you do place of all positions, you classify this symbol, and thanks to the cache of this function, you don't need to do this again, so you get the 5-minute cache, and you know if you have to trade or not. So this has been already cached, because if you go into symbols, no, if you go into trend, you can see how this has a cache of 5 minutes. So we don't have a problem in order to determine if this is a trend or not. The problem is that in order to do so, you need the score of your you need the score. So in order to do so, we need a proper, yeah, because otherwise so this is it. So okay, let's see how all of this goes. Google Gemini. Okay, so let's copy and paste all of this. Okay, I want to cache also results from per symbol and per 48 hours, and let's assume that the original function is renamed to whatever real. So that we do not have to modify it. then the new method should make a should make a hash value of all of the key value parameters of the method, so that has value serves as a key of the cache. In other words, if the same key value parameters are given to the method, it should return it if it's in the cache, but do it in such a way that the symbol parameter is ignored, because you are already going to have a symbol key in the cache as in the other methods that we have already done. Okay, let's see what it does. To implement the next dictionary structure, the first level is the symbol, the second level is the hash. The parameters ensure that if you change the loopback or the RSI period, the cache. Okay. Use the hash lib to create whatever. Okay, so trend time cache, timeout, time delta 48 hours, print trend time cache. Okay, this makes sense for each one of the symbols. If symbol has no more hash parameter sets, remove the symbol key. Okay, yeah, why not? So calculate trend with RSI, which is the whatever. Put 10 params sort keys to ensure the hash is consistent. Okay. Check cache. So if it's in here, you do this thing. Otherwise, you do this. So cache is called a real function with all of this. We have the result. So if the symbol not in trend hash, you create this thing, and then you save this thing at the parent hash, which where the hell is the param hash 0? Okay, yeah, that's what the hell. This is what I wanted it to implement, because I don't want to be caching this thing. Okay, but we don't want to cache this for 48 hours. That's not right. Wait a minute, that's not right. So let's put the wrapper here on the bottom. That's real. Let's put the wrapper on the bottom. Okay. So the wrapper. On the top, going to open trend.py so that I can see whatever it's on the top. So this needs to go into here. So this cache should be like 2 minutes, 1 minute. I'm not sure about this. 1 minute, yeah. 1 minute we should be going from one place to another. So, do we have JSON here? We don't. And the hash leaf we don't either. We already have datetime and time delta. So JSON and hash lib. So no hash leaf, no JSON, but yeah. So these ones, it's not needed. And now we are caching for 1 minute so that you can do this thing. Okay, so let's do this thing. Yeah. Rank chair. This one here. So now okay, what's the function name? Trend hand. And this is the real one, is it? Have we put real somewhere? Oh my god, this is very big method. This is the real one. Cache this thing. So now we should probably test all of these and see what happens, because we have done a lot of stuff. So maybe reset this thing like several times. Okay, and then this is more trade 7. Seems that it likes it. More trade 7. And more trade 7. More trade 7. I'm not sure if it's going to work. Too many changes. We also have fetch contract size cached. Yeah, probably this is what I mean, but I'm not sure. Okay, so apparently I guess that this fetch contract sizes thing, it's not properly called from main.py, and we should be using wait a minute. 290. Fetch contract sizes is not defined. So we're supposed to be using fetch contract size cached, isn't it? In here in order to okay, let's take a look at what the hell we have done in here. So it should be this commit, isn't it? So we have the contract size cached, contract size timeout, we have the pre-owned staff, and we have this fetch contract size cached, which calls fetch contract sizes. Oh, I see. This was actually doing this thing like this, and this is doing the thing the way it thinks it needs to be doing, but that's not right. It should be calling this thing with the symbol. Yeah. I see what's going on in here. So this needs to be fixed, if you ask me. So let me see, fetch contract sizes. So this should be something like this. Yes, this is 5 minutes, but we don't care too much about 5 minutes. And so this is symbol. I mean, this makes sense that it doesn't know how to do it because it's much difficult to understand what's going on in here. So hit the status, hit div, hit add main. So this was contract sizes. Yeah, contract sizes. So this should be this one with a 2, which we later on will refactor, if you ask me. So the same thing should be happening with the other one. So yeah. So basically we should be doing the same thing with this thing here. So this is the method that you want to be using, and that's it. So main.py, and this is mean price increments. Number 2. This is like number 2. Look at that. And yeah, I don't know. So IPA daemon, and let's see what happens in here. It doesn't seem to be yeah, low volatility symbols cache is not defined. What has happened? Okay, yeah. Low volatility symbols cache is not defined in This is main.py. Okay, let's take a look. Oh, look at that. Yeah, doesn't seem like we have to find it anywhere else. So it should be like this one, isn't it? So base symbols cache timeout. So it should be like this, if you ask me. Okay, so hit div, hit add main.py, low volatility, no, not volatility. I don't remember anymore. Low volatility, yeah, so it's cache low volatility symbols. So this is number 2. Number 2. And so we run this thing again, and now maybe key error timestamp. Prune low volatility symbols cache. If low volatility timestamp is known. Oh, so it should be working like this one here, isn't it? Okay, let me copy this thing here and just change this one here. So I guess that the other ones should work similarly. Okay, let me see. Hit add main.py. Let's amend the last commit, because yeah, what we have done is for the same thing. But now we should have the same problem with contract size, which also has all of this, isn't it? You have the timestamp in all of this, so base symbols, low volatility, run contract size. No, you don't. Contract size. I don't know. I really don't know if we need to do this thing again. I mean, I guess that something else is going to fail, but at the same time, I'm not sure about it. So the first time should take more time, if you ask me. Okay, look at that. It seems that we are asking some old symbols. That's nice. Okay, so if we go on to if we try to fork this thing, we want to try to, you know, we need to fix this thing so that cache. So yeah, it should be something like that. So create branch from here, which is going to be more trades 8, and then we want to cherry pick into more trades 8 all of this. More trades 8, more trades 8, more trades 8, and more trades 8, and more trades 8. Oh, look at that. It seems like it works somehow. Trend. Okay. How long did it take? Not too much, if you ask me. In any case, we're going to just check. While this seems to be working, let's see. Okay. So let's rebase like 10 of this. Let's see what we can do with all of that. So cache volatility, low symbols. Do you like this? Apparently it likes it. Contract sizes. Does it like it? Yes, it does. And what about this one? Yeah, so we can squash all of this, if you ask me. Look at that. So we are going to need to update the okay, look at that. So more trades 8. Let me edit the video real quick. More trades 8. Okay, let's go back to the main video. And so I guess if you check more trades 7 and more trades 8, it should be the same thing. So look at that. Maybe I can cancel so that we can see what's going on if we you know. So let's have this thing like 10 times, twice. And now we can just ask for more trades 8 in each one of them. More trades 8. More trades 8. So APA daemon, and this is the first one. So now we should detect that it has to resume, and it detects it. Okay, I don't know, missing trailing params, so you don't trail. Maybe it's supposed to work like that. So let's take a look. Wait a minute. Do we have 3? Is it okay that we have 3 of those? Maybe yes. Cas, Avax, and Pendle. So Cas and Avax are short trades. CAS and AVAX are long trades. Yeah, and Pendle is a short trade. Okay. Let's take a look and see how well this is working anyways. Because usually... So 5 minutes. Oh my god, I mean, we have already lost a lot of whatever this is. 0.91%. Shouldn't we have a big candle upwards? Why the hell is this going down? Is it because we have checked this one here and somehow we have not seen this one here because of whatever? I don't understand. So what about the next one? Pendle. Pendle is a short, so we actually... wait, this is 1 minute. Let's go to 5 minutes. So somehow this is the 5 minutes candle that we are using, because I don't think we are using this one. So while this 5 minutes candle was forming, we decide to go on in here, and then somehow the price goes up. So maybe we are able to win something. So CAS, I think that CAS, the sell market, we are not going to, we haven't won anything. So CASPA, trade history, yeah, it's a loss. So we wanted to go up. I'm not sure why we wanted to go up. Maybe this candle here. Maybe I'm missing something that I don't know. What about AVAX? I mean, AVAX makes sense. This is a big candle. And wait a minute, AVAX 5 minutes. What the hell? Why would you enter? Yeah, maybe it's this candle here that we have seen, and then somehow we enter in this red candle that goes down. In any case, yeah, this is an uptrend. So you want to go up, but even then, it's quite surprising to me, like... So it's like that we decide with this candle on the left, but then we decide with the candle on the left that it's a green candle, but then somehow we wait for the price to be here, which I don't know if it makes too much sense or not. So yeah, I don't know what this is supposed to be doing, if you ask me. I mean, it's going to win probably, but at what cost? I mean, if I knew that there was this red candle, I wouldn't have entered the trade. I mean, we are lucky because this went down and we have the stop loss is less than the take profit, but at the same time, it's like we are missing something in here. You know what I mean? Okay, so let's see how this works. Look, we are about to have a take profit. Hopefully we win something, because usually we don't win with any of this. My god, I'm not sure what's going to happen here. 257, so we need to go upwards. Oh, look at that. I mean, 257, it's not, yeah, it's like it's there, or maybe it's not, so. And then we have Pendle, which I don't know what's going on with it. Yeah, so this makes more sense. So this is the 5-minute stuff that we are used to, where we just wait for, you know, for things to happen. 257. Oh no, the price is going down because of whatever reason it is. So that's why you test all of this with a lot of trades instead of just a few ones. But let's see what happens. At the same time, if you see down here, Pendle is going better. Look, both of them are green, but it doesn't matter too much. So have I seen Pendle? Pendle 5 minutes. Yeah, the take profit is not so good if you ask me. Let's see if we win anything with this take profit, so with this so small take profit. Because again, we are missing like the current price or whatever, so 0.20%, it's not very much. And AVAX is going up again. I don't know. I need to cancel all of this, run it for the night and see if we have won anything at the end of the night. But you know, what seems to me is that we are not getting the actual real values because we have a lot of stuff cached. And maybe some of the trades are not worth it because we are not checking properly the stop loss or whatever. That's something that we need to do in the next stream or whatever. So this one has been done. This one has been done. So Pendle is about to make a take profit, which won't be profitable if I'm right. I don't know. Maybe not, but you know, Pendle seems to go downwards, so it makes sense that this goes downwards. So for now we have 002 whatever, and this is not going to be profitable. I mean, I'm not sure, but at the same time I'm pretty sure that this is not going to be profitable. So it's something like 0, 0. Okay, so 0 minus 0022. And now we're going to add whatever it says in a moment. Here it is. Look at that. So minus 0.0518. So we have lost in this trade. Yeah, we don't have position history in here. Now we need to know. We need to see what the hell happens in here in AVAX, because it can go down or it can go up. That's something that you know, one trade from one place might not be another trade from another place. So we need to log in here to see how much is there of each one of them. So maybe we should try to do that. Yeah. So this is what we have right now. Yeah, please end the trade so that I can refill the stuff and then take a look at the results when the so AVAX. So AVAX is going, Avalanche is going to lose also. I mean, if it does not lose, it's going to be very, very, you know. Anyway, what I'm going to do is to close this thing here manually, and that's it. I don't want to you know. So I have closed this thing manually, and now we should be able to transfer out from here to here, I guess. Yeah, this didn't work unless you did it from here somehow. So you move this into here, then apparently it knew how to do this thing, and now I can transfer in 34 from the master spot to futures. So now we have 34 in each one of them. In each sub-account. So let's let's try this thing. I mean, it now works, isn't it? And we are in more trade 8, so 1, 2, 3, 4, and 5. Yeah, so it detects that there are no more trades and it starts new cycle. So we will see tomorrow how well does this works. I guess that the time is that this works every 5 minutes right now. I'm not sure, but I think that's how it works. So thank you very much for watching. Bye.